Hi everyone, I'm Mike Broda. I'm the managing director of TerraQuip Drilling Equipment. We've had the company for 8 years now, and last year we also started the TerraQuip Talk podcast. Now, this is the podcast where we're trying to give a voice to our industry. So if you want to participate, if you have something to talk about, please hit me up. Come right here in the studio. Let's have a chat about it, a discussion between professionals. Or if you have a topic that you want me to tackle, I love talking about this stuff, right? So please give us a like, send us a message, send us some good words, hopefully, and we can't wait to hear from you. Cheers. Hi everyone, welcome back to TerraQuip Talk. This is the podcast where we dig deep, literally and figuratively, into the world of foundation drilling and heavy equipment. I'm your host, Mike Broda, and I'm thrilled you're tuning in today. You know, I'm very appreciative of my friends in the industry that listen to this podcast. So thank you for that. The purpose is to reach more people out there that are interested in this field, especially the ones looking to get into drilling and especially piling, because that's our specialty, right? So I thought, you know what, why not do an episode explaining the lifeblood of deep foundations, and that is the piling technologies that we drill with, right? What are the piling technologies? Now, whether you've been in the dirt for 20 years and you have a ton of experience, or you're just a young project manager that's trying to make sense of a geotech report, for example, this episode will be for you, right? And what I'll do is I'll break down the major piling technologies out there. I'll explain exactly how they work and when you should use them and the types of rigs that make it all happen. And yes, I don't care. I will talk about my competition as well and whatever they're good at. Because in the end of the day, you know what? There's place out there for everyone. And as long as you're buying a machine that has a long-standing history, it's from a manufacturer that's built thousands of these things, you can't go wrong. However, what does make a difference, in my opinion, is the local support you have in terms of after sales. Because these complex machines, man, they're very complex and they're costly. And they're also very specialized. It's not like excavators, you know, when you've got literally hundreds of dealers and service shops all over the country to look after them. With piling rigs, in Australia at least, I'm talking about Australia because this is where we're active, we're literally 19 suppliers or dealers all over the country. And I can guarantee you, less than half out there actually have experienced qualified service technicians. At TerraQuip, we have a team of 5 service technicians, and it's something that we put a lot of time, resources, and money into training our technicians. Whether that was our manufacturers coming over from Italy to Australia to spend time with us and train us, right, on different pieces of equipment, whether it was us sending guys to Italy at least 2 weeks a year with everyone, we've done it. And we put ourselves out there on the line because we wanted to give good service. You're not just going to buy a machine. You're going to buy the support around it as well. So this is extremely important. And it makes me laugh that I still talk to some clients that, let's say we lose a deal, we find out about it, we call them, hey, you didn't even give us a chance, to price this machine. Oh, I'll be honest with you, I wanted someone, that has the service support, the after sales. And I'm like, do you know we have 5 service technicians? They're like, what? And I was like, yeah, come over to our yard. Come and see, come and meet the team. Look online at our website. Oh, I had no idea about this. Well, that's okay. Now you know. We actually had someone from a very large company recently coming over to see us. And at the end of our meeting, they came to see at our yard. The guys were there, 3 different teams working on 3 different things. And they met everyone from the office, from the spare parts, from the service. And they went, I am so impressed. I had no idea of the size that you are. It's like, yeah, man, we're moving. We're out there. Now, let's get into it. We've got a lot of ground to cover. Pun absolutely intended, yes. So let's get into it. Now, the first one, the oldest one, the old school is driven piles. They're the heavy hitters, so to speak. And think about exactly what it sounds like. You're talking a preformed pile, usually precast concrete, steel, or sometimes even wood, and then a physical device that hammers it into the ground until it has a load-bearing layer of soil or rock, or until the friction along the side of the piles is enough to support the structure. So how it works, this setup is pretty straightforward. You have a rig that's equipped with a massive hammer. This can be drop hammers, diesel hammers, or the modern ones, of course, are hydraulic hammers. And the way you do it is position the pile, you set up the hammer on top of it, and you just bash it down. You drive it down, right? And what it does is, as it goes down, it displaces the soil around it, which actually compacts the surrounding earth and increases the friction. And it improves the soil capability as well, right? So when do you use this kind of piles? Look, they've been used for hundreds of years, right? The driven piles are usually fantastic for marine environments, coastal areas, and anywhere you have soft compressible soils over a hard layer. So the soil composition is important as well, not only how old the technology is. And in terms of the rigs that you'd use for this, of course, you're looking at dedicated pile driving rigs such as Yuntan. Yuntan is a fantastic finish rig. I used to sell for a very short period of time with one of my previous companies that I worked for, Yuntan rigs, and I was absolutely blown away the level of precision, dedication, and professionalism these guys have. I hope they're doing well. I haven't spoken to them in a while, but yeah, Yuntan rigs are freaking amazing. And of course, you have some other ones there as well that make incredibly dedicated piling rigs, driven piles. Or there's also the setup where you have literally just a nice hammer or Delmac hammer or whatever that's fitted on a traditional crane suspended hammer. Now, what's the downside of this technology? Why is it not used more? Well, first of all, we did said you have to have the ground to allow you to drive piles, because if you have something like in Melbourne, some areas is like full of basalt, from like 1 meter down, no way you can use a driven pile, right? But there's also the noise you have to keep in consideration, the noise and the vibrations. If you're working in a dense urban area, driven piles are a great way for the neighbors to hate you. So when noise and vibration are an issue, you have to move into our next drilling technology, piling technology, and that is bore pile or drill shafts, or in Australia we call it kelly bar drilling. This brings us to the absolute workhorse, as I said, of the modern foundation industry. Bore piles, specifically using kelly bars, is one of the most popular ones in the recent years. Why? Because it covers a large, pretty much any type of ground conditions, right? So if you work on a major commercial site, a bridge project, or high-rise development, chances are that you're going to see a rotary drilling rig there with a kelly bar on. And how it works? Well, instead of displacing the soil by hammering it, they're extracting it, right? The rig uses a telescopic steel tube, which is the kelly bar, which is fitted at the bottom of it with a drilling tool. And this could be an auger for soil, if you have soil. It can be a drilling bucket if you have wet conditions, or it can be a core barrel for very hard rock formations. And the rotary head of the rig spins basically the kelly bar, then the tool digs into the earth, and then the whole assembly is pulled out of the dump to dump the spoil. And of course, you repeat this process until you hit your target depth. And then once you reach the desired depth, what you do is you dump there the steel reinforcement cage, and then you pour your concrete. Or you pour your concrete, and then you dump the cage. I've seen it done a different way depending on, what the situation is. Now, kelly bars generally come with two types. There's friction and there's interlocking. You see, friction kelly bars, they can be used pretty much just in soft soils, because when you hit hard ground, you need to have mechanical locking kelly bars to transfer that massive crowd force of the rig directly into the tool. Now, I'll just say this. In over 15 years that I've been working in piling, I think I've only seen once or twice a friction type kelly bar. Very little use. Pretty much nobody's using them anymore. There's no point. You have interlocking kelly bars, which can be J-lock or multi-lock. And with this, I'm going to talk a little bit about IMD and the reason why in the last few years, we just moved on as a standard to J-lock. Now, our IMT machines can use both multi-lock and J-lock, but because the Australian clients, the Australian operators are more used to J-lock because of the use of Bowers and other, CASA and so on and so forth, with pretty much everyone uses J-lock. We said, you know what, we get it. Why? Because of the maintenance. So I was actually talking to an operator yesterday and he was saying, man, I love multi-locks. I'm a huge fan of multi-locks. But you see, the trick is he's only started drilling 5 years ago. We started with multi-lock in Australia 8 years ago. So to kind of like the people that are new to the industry, they don't have that sort of preconceived idea. With J-Lock, the multi-locks were great. They loved them, right? They understood them. Not only the new ones, there's some old ones as well that understood it. And they knew how to treat them. And they don't need the maintenance as much. We know rigs out there, IMT, they have over 3,000 hours. And please believe me, we never welded those locks. But then we also had situations that after 250 hours, the locks were done again. It's just that the way the operator deals with it is absolutely important. And we did say this, the tool is the most important. Secondly is your operator. If you have a good operator, it can make a good machine, it can make a bad machine look good, or the opposite, if the operator is not very proficient. Now, another thing that I want to mention here, and this is really important, very few people know that IMT, the founder of IMT, Giulio Acroi, is actually the inventor of the Kelly bar, of the locking Kelly bar that everybody's using nowadays, the telescopic locking Kelly bar. So IMT has huge tradition with this sort of stuff. I didn't just represent them because, I needed a brand out there. In fact, I didn't even want to start a business 8 years ago. I started because I saw how important the pioneers that they have been in this industry. And one of the fact that they came up with it, they revolutionized the industry all over the world, is they patented the first multi-lock telescopic Kelly bar. Because until then, they were like square friction. So not very efficient. It was very limited use. Okay. So anyway, I wanted to have this small little bracket here to discuss about the Kelly bars because they're so important. Actually, very few people know, out of the entire rig, the Kelly bar holds a lot of knowledge and a lot of refinement. It went through a huge trial and error process, a very long process, because they have to be extremely strong. They have to be light enough. They have to allow the locking and the unlocking. They have to transfer all the load. It's basically, the connection point, the main connection point between the rig and the tool, what's happening in the ground, is the Kelly bar. So it's an engineering marvel, honestly. Now, when you talk about, we spoke about the reason, the hard rock challenge, that you use Kelly bar, especially because you can cover the hard rock ground as well. And of course, what sort of rigs you've got there? They're extremely good at hard rock. Of course, Bauer, IMT, there's Casa and so on, right? But I have to say, and I get asked this a lot, when it comes to Kelly bar drilling in hard rock, the game completely changes because you can't just use any rig. You need serious structural integrity, incredible torque, and a rotary head that won't tear itself apart. This is actually one of the main reasons why we choose to supply IMT drilling rigs at TerraQuip. And if you know IMT, you know they're essentially built like tanks. When it comes to hard rock drilling, especially in remote areas, IMT are legendary in the industry. They just have the power to go through any sort of like hard rock conditions, within limits, of course, in the areas where other brands are struggling. And honestly, you don't need to believe me, right? I'm not just here, I'm here to walk the talk. Everybody knows I told them this. If you want to try an IMT, especially if you have another rig that you work with, another brand in hard rock, I'm happy to do a demo. I'm happy to do a test for anyone out there. Try it. If you don't like it, that's fine. Give it back. I'm not going to charge you anything. I'll leave it to you for the entirety of the project to drill for free. But if you like it and if it drills better than your current rig, of course, it's got to be on par. You can't put an IMT or 40 next to a BG30. It's got to be, right, the equivalent size. But if it does do a better job, you buy it. And this is what allowed us to actually sell a lot. We went from 0 IMTs in Australia to now over 40 machines. So I'm very proud of this. It's because we have a good product. I've spoken this with a lot of the customers, and I gave this example years and years ago. It was at the beginning, we had an IMT A140 drilling next to a very popular machine that claims to be a rock machine, but it's not. It just shakes to pieces, right? And they were just side by side. It was 900 diameter. It was drilling for the transmission lines. The drilling depth was about 5.5, 6 meters. And we followed that machine closely. We actually brought a lot of clients. We traveled. I pay for the travel. I said, come and watch this, right? And that's what allowed us to make a lot of sales. That particular job there, it was back 6 or 7 years ago. 2019, 2020. So the IMT A140 was there. Another 40-ton class machine was there, competitor, side by side. They were drilling 900 diameter. The IMT A140 was going through 11 to 13 meters a day of hard rock drilling, of basalt drilling. And it was brutal. Even for the IMT, it was a brutal job, right? The other machine, I'm not going to say the name, of course, I don't want to lose it under my head, was going to 3 to 5 meters a day. We're at least double the production in hard rock. And again, you don't believe me? Please come and try it. We have an IMT A140 ready to sit there in stock, ready to go and drill. I'll give it to you, as a demo free of charge. Just let me know. Hey guys, just a second. I just want to say this. Thank you so much for taking the time to watch this episode, to listen to us every single week. It gives us immense pleasure to talk about our industry. We want to give a voice to our industry here. So if you enjoy this, if you find this interesting, please hit that like button, share with someone, subscribe. All of this helps us a lot. It means the world to me. Thank you so much. Now let's get on with the episode. And to end the Kelly bar, of course, this was the chapter that was the biggest one because it is the most popular and it has such a broad coverage. Let's talk a little bit about the downside of it. Well, the downside with Kelly bar drilling is the collapsible material. So what do you do when you have collapsible material? Because you can imagine you're 6 or 7 meters down the hole, and then you've got the walls of the pile collapsing. You can't extract. You get your Kelly bar and your tool stuck there. And the tool, let's say, is 10 grand. A Kelly bar is roughly 80 grand, 100 grand. So you can lose a lot of money very, very fast because you can't get out of there, right? It gets stuck unless you just dig a huge pit around it, for 7 meters. So what do you do when it's collapsible material? Well, either you use casing. So you literally use it's like a canister, like a tube that's empty inside. It's like 16, 20 mil, or 12 mil thickness, depending the different sizes for different diameters. And you just drive it in with the rig and you drill in advance of the casing. And then as you progress, you continue to insert the casing, or you use a crane suspended vibrator to vibrate the casing in. And then you drill inside the casing, you come out, the walls stay perfectly. And then you concrete it, you put your cage in and you extract the caging, and that's it, you extract the case. But there's also the option, and that's piling technology number 3. You go to continuous flight auger technology, CFA, or Auger's cast piles. So moving on, we talk now about speed because CFA is fast, right? Continuous flight auger. Imagine it's like a giant drill bit, like you use, let's say, for example, in your garage, but it's 15 meters long and it's anywhere between 350 mil diameter up to, I've heard of CFA even 1200 diameter. That's your continuous slide auger. The rig drills, in this case, they're massive, right? And they go into the ground in a continuous motion. That's why it's called continuous slide auger. So it doesn't come up until, like with the previous technology with Kelly bar, until the pile is done. That's the only way you come up. So once you reach the design depth, that's when the magic happens. The auger is hollow. It's a hollow stem. So through the middle, you actually run the concrete. As the rig slowly and steadily pulls the auger out of the ground, concrete is being pumped down at the same time through this hollow stem. So the hole is completely supported by the soil of the auger and the concrete being pumped in. So this way it never collapses, right? Once the auger is completely out of the ground, you have a column of wet concrete. You just plunge that steel rebar cage in, and that's your pile, right? And a good way to know if you've done a good job, because you can't see it, right? You can rely on the computer, but there's so many things that can happen in the ground. You can have water ingress, you can have a lot of cavities and things like that. How do you know if you got a good pile? If your reinforcement is going in not too fast, but also not too hard. You don't need to. I've seen cases where the cage doesn't go in. They try to force it with the excavator, and it can happen. It can happen to anyone, right? It's not something to talk negatively about. But you try to push it really hard, and then the cage goes banana, right? Because there's so much force on it, but it's got nowhere to go, right? That means it's caught something on the side of the pile. Now, when do you use CFA? Like I said, when it's unstable soils, when you have things like sand, gravel, or high water tables, where an open hole would just cave in, CFA is great, right? It's incredibly fast, very quiet, and has almost zero vibration. Now, what's the downside? Because there's also downside with CFA. Well, it can be a lot more accidents happening in CFA, right? We have all that concrete going up in the air. You have the snorkel up in the air with the swan neck. You have the swivel. I've seen it numerous times when they don't look after the swivel very well, then it seizes, and then the rotor is trying to turn, and it turns into a reaction bar. It breaks the reaction bar and can cause serious damage on the rig. This can be blockages, and there's been very unfortunate cases of blockages. Anyway, we're not going to go there, but yeah, it's very dangerous. And it even happened to me. I think I was 1 year into the job about 15 years ago. I was on a job site in Sydney, and it was a big, I don't know, bower lever or something like that. And the concrete hose burst, right? For whatever reason. Even sometimes they lay it on the ground and they drive with the excavator tracks on top of it, so that it decreases the integrity of the hose or whatever happened, that the hose burst and it sprayed us with concrete like crazy, like head to toe. It was on the side of a adjacent building, cars, some people, got sprayed. Very interesting, right? But it can be very dangerous. And the downside with CFA is you gotta have a very organized job site, the logistics of it. You have the concrete truck exactly when you're at the bottom. If, for example, your concrete finishes and you need to wait for the next concrete truck and you're like halfway up the pile, you can't wait for too long, because then your concrete can get hard. You can't put in your cage anymore. So then you just wasted that concrete. You need to re-drill it, right? Now, what sort of rigs are used for? Most modern rigs, rotary rigs, are multi-purpose. They can be, and take IMT for example, they can be used in Kelly bar or in CFA. And then of course you need a good concrete pump, like Klein for example, and the monitoring system to ensure that the extraction rate matches the concrete volume. Now, I've seen a lot of, and I even know a company that has like multiple rigs, and they've been drilling successfully. They've been very, very successful at it for the last, 12 years. And they've never, please trust me, they've never turned on a CFA computer, even if they have it. It's all by feel. And they do amazing jobs. They don't waste a lot of concrete. They drill in really difficult conditions. So a lot of it is the operator feel, and how dedicated the operator is, how professional it is, right? But as I said earlier, when it comes to CFA setup, we have the rigs, IMT rigs. Pretty much every single model is set up for CFA as well. Even the rigs that we have in stock right now, they have CFA kits. We have the Klein pumps for concrete pumping, the most precise concrete pumps on the market. And then we have the G&H computers, which are very, very easy and very reliable, very versatile. They can be installed on any rig, any drilling technology. We even priced, by the way, we priced recently, and I think we're going to install it, a G&H computer for a trench cutter, right? So very outside the box. In fact, the client asked me not to talk about it, so I'm not going to talk too much about that stuff. But just to give an idea that any sort of drilling technology out there, any sort of piling technology can be covered, can be surveyed, monitored, and all the pile parameters can be analyzed and shared with the help of the Hatlapa computer. Very, very good system. We started in Australia, I think, when I started with them in 2019, because they didn't have a dealer here. It was only one computer installed on a big, some sort of big CFA rig. I think it was a Boltman. And now I'm happy to count, we have about 27 computers that they have installed on different sort of range of rigs, even the ones that have like the SF45 and stuff like that, they have their own computer. Now, we spoke about the downsides. We spoke about the CFA advantages and when they're used. One more thing that I want to add here in regards to CFA and IMT, I want to emphasize the fact that traditionally IMT was known as a K-bar rig. That's absolutely true. They were considered the workhorse of the industry. Not very known for their CFA capabilities. They had rigs even before I started with them in 2018. They had rigs and models that were in CFA, but they were not as popular. Right? There were other brands out there that were specialized in CFA. Now, when I started working with them, I told them, I said, guys, we need to be incredibly good for Kellybar, CFA, low headroom. It's got to be multi-purpose. I'm not going to work with you guys in Australia because in Australia, we have literally about 40 to 45% of the market is CFA. You got to have a very, very good range. And that's why it's so interesting in Australia. If you think about it, we have very broad spectrum of grounds. You have everything from basalt, granites, really, really hard stuff, up to 300-400 MPa strength, all the way down to like swampy material, like for example, Sydney Olympic Park, where it's just pus is nothing there, right? So I told them, I said, we need to be extremely good at CFA as well. So they put a lot of research, they put a lot of time and resources and energy as well as us to come up, with every single model to have a good CFA setup. And I'm happy to say now that out of 40 something machines that we sold, IMT machines, I think they're about a quarter, 20, 25, 30, maybe a third. A third of them, they have the CFA setup. And in fact, we have companies out there that do primarily just CFA, and they have 3 or 4 IMT machines, right? So I think we've done a really, really good job developing this application. Now we're moving on to kind of like this is like a spin-off of a CFA, and it's called FDP, full displacement pile. Now, what does that mean? Well, if you like the idea of CFA, but you don't want to deal with all the dirt coming out of the ground, right? That brings you to a full displacement pile. Not that with CFA, you've got too much spoil like you have in Kellybar because you excavate everything. In CFA, there's a little bit less, right? Because there's a little bit of a displacement, but it's also extraction at the same time. And in fact, there's some types of CFA out there, I forgot to mention this with CFA, where they literally just corkscrew all the way in, right? They try to disturb the material as little as possible. And then as it comes up, right, it does some extraction, so a lot less displacement. But if you continue to drill, depending on your RPM and your ground conditions, you can do a lot of displacement. Now, how FDP works, right? It looks like CFA, but instead of cutting and lifting the soil out there, the tool at the bottom of the string is literally shaped like a bullet, like a torpedo, depending on design. There's so many designs out there of FDP. And as it drills down, it physically pushes the soil outwards, compacting the walls of the hole. And it's basically just like CFA when it comes to concreting, because concrete is pumped through the hollow stem as the tool is extracted, right? Why is this awesome? Well, 2 reasons. Number one, because you're compacting the soil laterally as well, you drastically increase the friction capacity of the pile as well. But secondly, this is a big one for project managers because there is almost no spoil. So if you're drilling in contaminated areas, we spoke about Sydney Olympic Park, which has some contaminated ground, paying to haul away all that toxic spoil can destroy your budget. So FDP keeps the dirt in the ground. Now, because you're pushing dirt rather than cutting it, FDP requires a massive torque and massive pullback capacity, right? So basically big rigs. Again, those heavy duty rotor rigs, you'll see doing this work. And in fact, with IMTs, you've got that massive torque. It was actually an operator, just an example, it was an operator the other day telling me, man, IMT has really good torque. Like it just wants to drill, right? It just wants to turn. It doesn't, we had 900 diameter CFA pile on a 40-ton rig. It's actually online. If you haven't seen this, it's called IMT A140 CFA record, 900 diameter, down to 17.4 meters. And you see that rotary just spinning. It doesn't bog down like it does with other rigs. You don't only see displacement pile. The tool is the most important component. And as I was saying earlier, the actual tool, there's so many designs out there. And it was a company, it was very interesting years ago. I'm not sure how they went, but I heard they had this tool that was actually doing the compaction on the extraction, because on the extraction, you're benefiting for a lot more force, right? Especially if you have a 4-pound line CFA like the A140 has, you have massive extraction. And you'll see it in that video that I was talking about. You see when it's extracting, it's not even dropping an RPM. It's not stopping on the way or being intermittent. No, it's continuous slow pull. And this displacement pile was actually very smart because it was doing the compaction on the way up. I'm not sure how they went with it, The design looked amazing on paper, and I think the testing went amazing, but I'm not sure how many people bought it. And in fact, in Australia, I haven't seen it many times. I think I've seen it once in New Zealand, and maybe a couple times in Australia in the East, but that's pretty much it. Now, we're halfway through the major technologies. I want to make sure, I want to say this, I don't really say this enough, but guys, if you find this useful, make sure you hit that subscribe button and give us I usually don't like asking for likes and things like that, but try to share this, especially this is more like a beginner episode. Try to share this with, people there from the industry that are interested in this, or they're just starting. I think that they'll find this interesting. With this episode, we're also sharing a lot of images. As I talk, it's not just my face talking here, but I'm sharing footage that I had, from years of being in the industry. Now, moving on, we have the Micropiles or the Minipiles. So if we scale down things a bit, not a lot, but a little, like let's talk about Micropiles. And sometimes you don't need to have, you don't have let's say the luxury of a wide open job site, but you still need to put a foundation pile, let's say, for example, inside of a basement of an existing building. We don't have too many of those in Australia, but I think it's getting more like they're trying to protect them through heritage building, right? And you can't bring a 100-ton rig in there. So how it works, you need to do micropiles. They're high capacity, small diameter piles, usually between, let's say, 100 and 300 mil diameter, down to anywhere between let's say 5-10 meters up to like 30 meters, right? And you drill them with a small hole. You drill a small hole using a casing or an auger. You drop in high strength threaded steel bar and pressure grout around the hole, right? Because you use high strength steel and high pressure grout, it usually bonds together tightly to the surrounding soil and to the rock. And these piles can hold staggering amount of weight. Right, so very good load bearing capacity. Now, the rigs for this, of course, you're going to use specialized compact crawler rigs, such as brands like Marini, Clem, Hoodie. They're very famous for this, very good machines. They can run on electric or diesel power pack and can literally crawl through a standard set of double doors, your living room doors. And of course, here we can't not talk about Marini because they are a premium product. Is the company that we're representing since 5 years ago. We've had a great ascension and progression with them in terms of the volume of rigs. Of course, Marini are very, very known for slope stabilization, quarry drilling, and things like that. But they're actually incredibly good and versatile. They have very, very innovative machinery for complete anchoring rigs, which can also they have the rotary to do micropiles as well. In fact, we have right now the MRC35, we have it in stock. It's ready. It's going off for rentals or for purchase or hire to purchase. So please give us a shout. There's a video online as well explaining all the angles that it can do. It can drill above itself, under itself. It's a very, very versatile rig. And in fact, the MRC35 is the flagship of Marini for micropiles as well. So of course, I got to give this a shout. It's the product that I represent and I truly believe in. Okay. Now, moving on with something very, very interesting, and that is soil mixing or deep soil mixing, DSM as they call it. This technique is less about creating a single pile and is more about literally changing the nature of the earth itself through deep soil mixing. So how it works, I remember one of the operators in New Zealand, they call it spinning. So how it works, imagine a massive kitchen mixer, but instead of extracting the bad soil, you blend it in place with a cement or lime binder. This rig uses single or multiple mixing shafts with paddles on the end of it. It drills down, injecting grout and churning the soil. When it cures, you're left with basically this column of soil cement, and you can overlap these columns to create this massive retaining wall or waterproof cutoff wall. Now, when you use it, well, there's certain grouts that can allow this, and I know this technology attracted quite a bit of controversy, let's say it, because it's not really seen as structural. It's just seen as soil improvement, right? So ground improvement technique rather than foundation building technique. But anyway, that's a discussion for another time. I'm not going to get into politics right now. When you use it when the existing soil is just, let's say, soft, right? When it's pretty much terrible, right? Like super soft clays or loose silts, and you need to improve the ground bearing capacity without hauling thousands of truckloads of dirt away. Okay, and that's basically when you use it. And in fact, I want to give this example to a very, very interesting technology that IMT has done. I think it was in Japan years and years ago. They had this 80-ton or 100-ton rig that was drilling with 3 rotaries. It was a mix of kilobar, case drilling, as well as soil mixing. And in fact, I have a video about this to show and explain, because this is very, very interesting technology. It was used for seismic piles in Japan. I'm pretty sure it was Japan. Okay, let's have a look.
IMT International, leading manufacturer of drill rigs, is pleased to present the AF460 multi-rotary drill rig. The machine has been equipped to carry out piles in soil mixing reinforced with steel pipes. For this reason, it is equipped with an upper rotary A connected to a cutting tool and a rotary below B for the mixing of the earth with the cement. A rotary C equipped with a device for the driving of casings, for the removal of material, and for the introduction of the reinforced pipe. The final pile is made up of a corrugated pipe and steel, immersed in ground mixed with water and cement. The pile proves to be very reliable and resistant, and is particularly suitable for anti-seismic construction. The method of execution of the pile of the AF460 multi-rotary drill rig is the following. Part of the material is removed to control the cement mixture and prevent it from coming out. For this purpose, a casing is first inserted. The pipe is connected to the rotary C by the hydraulic locking pins. The Kelly bar is then mounted inside rotary C. The excavation begins by means of a hydraulic device in the rotary and a tool. By aligning rotaries A and B with the rotary C, the tools are mounted and the soil mixing begins. Cement and water are pumped through an internal tube and come out of the cutting tool. Rotary B turns at high speed to guarantee the uniformity of the earth-cement mixture. The steel pipe with external grooves is lifted and is passed inside rotary C, pressed and pushed in the ground. Once the casing is extracted, the machine is ready to make another pile.
To be honest, I was appalled when I first found out about this technology. I told IMT, I was like, why isn't this online? Why nobody knows about this stuff? Like, even I think I didn't find out about it until like 1 or 2 years after being with IMT. I was like, you guys need to push this. You need to show people what you're doing. For example, not many people know that the IMT are the inventor of the Kelly bars. Mechanical locking Kelly bar. That's a huge invention. That's, pioneering the industry basically, right? But anyway, each company, I guess they just rely on word of mouth rather than actually putting money into marketing like we do here at TerraQuip, right? Anyway, we're moving forward. We're moving on with the seventh type of piling technology, and that is the diaphragm wall or the slurry walls. Finally, touching base on this technology, also known as slurry walls. If you ever wonder how they build underground subway stations or deep underground parking garages for skyscrapers right next to a river, this is how. So some people, they use the CFA, the CSP. That's very, very complicated, and chances are that something will go wrong. It's incredibly difficult. In fact, in the whole Australian market, I think there's only one company that I would say that's very, very proficient and has a ton of experience with CSP. And even they said we're still learning. But a more safe way that a lot of companies rely on, although it is very expensive and you need a lot of gear, is diaphragm wall. And how it works? Well, you excavate a deep rectangular trench, and then to keep the trench from collapsing, you constantly pump in a bentonite oleopolymer slurry. And this slurry being heavy, it holds the walls open. Once the trench is dug, you lower a massive prefabricated steel cage directly into the slurry, and then using a tremie pipe, right, you pour the concrete in from the bottom to the way up, which majority of the pile should be from the bottom to the way up in order to push out and you have to have that integral pile. Now, the concrete is heavier than the slurry, and of course it pushes, as I said, everything up to the top where it's pumped away and recycled. All that slurry, you can't just throw it away. You just separate the mud, whatever, and then it's a lot more complex technology. Avo Piling are absolute champions at this. Have a look. David actually came here in the studio and we had a discussion about it. They're one of the most experienced people I've seen in doing this and being very, very successful in Australia with this stuff. Now, what sort of rigs you use this? You don't use rotary rigs for this. You actually use crawler cranes equipped with massive hydraulic grabs or specialized trench cutters like the hydrophrase. Now, these are massive pieces of equipment that literally mill the earth. That's how they do it. There is so much, honestly, to talk about in terms of piling technologies, but we don't have the time. You know, the time is limited. We're up to 40 minutes this episode. Okay, we're aiming at 30 minutes. So there you have it, guys. From slamming steel into the ground with driven piles to heavy-duty rock drilling of Kelly bar, and all the way up to blending the earth with soil mixing. These are in general the piling technologies. Of course, there's spin-offs, and different sort of, let's say, adaptation to these methods and variations to the method depending on the ground conditions, because you need to adapt, right? But the biggest takeaway from this is there is no one size fits all in foundation drilling, right? The geology dictates the technology, first of all, and if you have unstable sands, CFA is your friend. If you have highly contaminated soil, you got to look at FTP. And if you're staring down at a geotech report that shows 20 meters of hard rock or basalt, well, you make sure you have an IMT. No, I'm kidding. Any other rig right there that's established would be good. As we always say at TerraQuip, having a machine like IMT in your fleet for those rock jobs isn't just a luxury. It's the difference between being profitable and burning up tooling and your timeline. Okay. I hope this breakdown helped clarify the piling landscape for you. And if you have any questions about these methods, or if you're trying to figure out what rig is right for your next project, reach out to us at TerraQuip, because we're not just drilling. You just tell us what machine you want. No, we're a solution provider. You help us. You tell us exactly. You literally give us in strict confidentiality the geotech report. We share it with our engineers in Italy, whether it's the engineers from Marini or from IMT, and we come up with the correct model for you. This is how we work. And then we don't just give you a machine, we also hold your hand throughout the project if you're someone new that's just starting. Thank you for spending the time with me today. I hope you enjoyed this episode. I hope you found it interesting, and I was able to share some knowledge that I gained. Now, stay safe out there, and please remember, if it's not turning, you're not earning. Cheers. Hey, thank you again for watching this episode. I hope you found this interesting. Now, if you guys are someone that have an interesting topic to talk about, or an interesting application, or an interesting technology or piece of equipment, and you want to share with us here with the audience at TerraQuip Talk, please hit me up. I'll be more than happy to hear from you. I'm always open to hearing new ideas about technologies, about how we can make things safer, first of all, in our industry, more efficient, and just better overall. So if you have an idea, please hit me up. Send me a message. You know where to find us.